Okay, my friends, so really boring quizzes this week. Just trying to tease out some of that lingo that we'll be using the rest of the course together, in particular p-values. So, and there's also a lot of like lingo, non-statistical lingo, like contextual lingo. For example, this one, we've got hypertensive kids, which I'm shorthanding HT, and then I've got learning disability documentation, which I've got LD. So what we're trying to figure out is we're trying to figure out if there's any kind of association between hypertension and increased risk for learning disabilities. That's what we're looking at in this study. Okay, now the null hypothesis is that there's not. There's no difference between hypertensive children and non-hypertensive children and rate of learning disability, because that makes the most sense. Assume there's not and then collect data. If you get data that shows they're not, oh well. But if you do, then it's, oh wow, there's an association. So that's what the p-value tells you. This p-value right here, it's less than 0.05. It's less than 5%, which means the chance we got the data from the study, assuming the rates are the same, is less than 5%. That I just highlighted right there is the answer to number one. A p-value is less than 5%, which means the chance we should have gotten different data is bigger than 5%, 6%, 7%, 8%, 95%, some larger percentage, which tells us that it appears that the children with hypertension probably do have a different rate than those without hypertension. Now, as to why it appears, that's not what I'm asking down here. Here, I'm just asking, why does it appear that children, or why does it not appear that children with hypertension have a different rate? We have no idea why the hypertension is associated with the rate of learning disability. What I'm asking is, how can you tell by the p-value? Well, because the p-value is very small, less than 5%, which means it's hard to believe the data came from this null hypotheses sampling distribution. If you're assuming it's the same and you get an outlier, which is what p less than 5% means, you got an outlier, that means it's too hard to believe. Yes, there's a chance they could have come from that sampling distribution, but it's too hard to believe it. It's easier to believe that it comes from a different sampling distribution, meaning they have different rates of learning disabilities. Maybe increased, maybe decreased, who knows, but different. All right, like I said, a little bit boring, but stuff you can just pull straight from the report.